Python turtle library, you can create a small game of 4 cars or 4 turtles running towards a destination line. Let's see that how what I mean by that. So as you can see, there are 4 turtles running, and whichever reaches the cross line first, your that turtle kind of rotates and shows that this is the turtle winner. And this is a very true to this is a very true performance indicator, because you can see when the turtle reached that destination, uh, the turtles were running at some random speed, right? That random means obviously you will be definitely be adding a random variable to it. Each turtle should be running at some random speed, and all the turtles will be given the equal chance to pick a random number out of a random pool, right? And going towards the destination. Let me just run it one more time, and I will take a screenshot of it so we can talk about it. So I have taken the screenshot of the game just it was running, because I can put a key press until the key press or input button is not pressed, the program will continue to run. So as you can see, the turtles, this is the this is my space that I will be creating. Under that space, I will be having a heading here called turtle race. And at the end of the race, I will have something called which turtle wins. And there's a little bit of there are 4 turtles with different colors. One is uh, blue, one is purple, one is yellow, and green. Then here, this gives me a little bit of feel of a dirt in which the turtles are running. And then this is a nice fancy line, and there's a logic to it that how I can create this destination line, this destination cross line. We can come to that, but imagine there is an imaginary line here somewhere to which all these turtles will gonna hit. Right, this imaginary line is there somewhere where when this turtle reached here, looks like this guy is winning, but this guy is very close as well. So whoever reaches, I don't care at the moment, they are getting they are moving forward, and I'm using the word forward because we will see a forward in there. They are moving forward, on all of these turtles are moving forward at the random speed, and that random speed is equally given opportunity to all of those. So when you have a race, whoever is standing in the race at this point and leaves this race should be given equal opportunity depending upon their leg size or whatever the random is. If they are equal heights and everything, or equal legs, then they will be running. So just think of it, everything is true to its definition, and when they run it, they will be reaching a destination at some point. When they reaches the destination, then there's a little bit of fanciness that will happen, that the turtle will rotate. But just think of it right now, let the turtle hit the line first. We will do this fanciness in a moment. We will do the rotation fanciness of the turtle moving when it reaches the destination in a moment. But let's first think of how we can generate the easy parts. The easy parts is putting the four turtles at their starting points. At the same starting point, they will all be starting at the same starting point, right? The other thing is at the same when the screen starts, they all will be given the equal opportunity to generate a random number between some numbers to increment. So depending upon if these two guys have a less random number getting generated, it's their luck. They're out of luck. But they were given the equal opportunity. So obviously this guy is winning. This guy is obviously losing. And you can see this turtle. So this is the screen that we are going to develop. What are the ways to develop the screen? So I have put out some headings, some comments in my section, and in that section, we will go those sections one by one. Uh, what is the first section? What is the second section? What is the first? So the code will be written. Code. I will be explaining you the code in different directions, but you should be able to understand that and put it all together. When you run this code, when I run this code, the sequence of the code happens differently. So the heading is put first, then this destination line put for second, then these turtles are made, and then the turtles are made to run. So the sequence of the steps are a little different, right? You might see different, but my first thing first is to explain you uh, that these are the sequence of the steps that will going to happen as well. Uh, but for the ease of use, we will see which one will be the easiest one to develop. Okay, so the difficult one to develop is the square boxes. Although it is explained here earlier, because when the turtle will be created, turtle is created after. So the sequence of the steps are really different than what we will going to understand first. And then when I'll say, look at the screen, what is happening first, what is happening second, what is happening third, you will see that, okay, Kashan has explained me the easier part of the code first, although this happened earlier in the stage of understanding. First thing first, what we need to do, when our program open, this screen should appear, right? What is happening in this screen? The screen setup is 800 by 500, x-axis and y-axis. The title that I want to put on the screen is called Turtle Race, and that's what it is happening. The background color is forest green. So far, so good. These three lines are showing me the window is created with this much width and this much height, and the forest green. The 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 speed at which the screen, so this becomes now a canvas for me, right? And the reason I say it is a canvas is because the turtle library is like a pen for me all the time. I think of it as a pen, and I'm going to draw this. So the speed at which I will going to be drawing will be the slowest speed. We all know that now. Heading. When the heading the when the heading is being when the heading is being drawn, we are going to go to a coordinate 100 by 205, and we choose the color white color, and we're going to put the heading called Turtle Race. And the font size, the font that we are going to choose is Arial, 20, and bold. So this will be a very dirty screen at the end of this lecture, but if you look at this, if I cross it out, I'll change the color here. Maybe change it. and here, x-axis and y-axis, right? I want it to be, and I know that this is my 0 by 0 point, right? This is my 0 by 0 point. I will get rid of all some of the lines just to be clear, or maybe take another screenshot if I need to. Here will be my negative x-axis, right? And if I remember one of the coordinates chart, that's why I always keep emphasizing that you have to keep remembering the coordinates chart yesterday we looked at. And I'm going to Google it again. Python Turtle Library Coordinate System. Python Turtle Library Coordinate System. Negative x, positive y, positive x, positive y, negative x, negative y. So if I need to start writing something from here, this is where my cursor. So negative x, positive y. If I go to my code, negative of x, positive of y. That's where my heading starts to write here, right? And what I told it to be, please write this in the white font, and the font is that I've chosen is Arial 20 and bold. You can change different types of fonts. Arial is the most common. You can use sans serif. You can use some other different type of font. I will not go over this because in the font you are going to pick up you will probably say Google font library in Python, built-in font libraries, and then it will give you this font. You can obviously include some other fonts from the web or Roboto from Google. Not going to complicate that. Writes some message on the screen. Which screen? On the turtle screen that we have created. So this will be the right message. Nothing else. It is not doing anything else. So far, so good. Heading is done. Screen setup is done. Heading is done. Let's put up the dirt. Where is the dirt? Dirt is starting somewhere at this point and ending at this point. So there will be definitely will be an X and Y coordinates involved. Let's look at dirt starting at minus 350 and minus 350 and going to plus 200, right? And pan down and move forward 700 pixel while range in 2. Okay. So you're going to create a line, but you want to also see that how this dirt is getting created. So let's do some fun things with it. We'll take it out. So let's take out some part of the code. We will be adding it later on once we understand some parts of it. So I took out all the part of the code. I just keep it this one so I can see how the dirt is being created. So I'm just gonna keep it in my notepad here and paste it. So I'll come back to it later. Let's see how the program runs now. Run without debugging. And let's put one thing that I put yesterday. I think it was input. It was Python wait for input. That's what I did yesterday. So I will use the input function input. So it will wait for the key so it doesn't disappear on me input. And then I can say input and let's say if I want to put a message, I think I can. If I don't, it will wait for my input. So run this. Here you go. Look at this screen. Now it will not disappear until I press a key or something, because it's now waiting for me to press a key. What is happening here? You started at this coordinate, right? And then you went to, let's see, range in 2. So let's change it. What's happening? You go. Let's remove this actually. What's going to happen this part? Remove this part. And let's just run this one. And this is what I like about here, because you can just get rid of some part of the code and then just watch it. So right now you are standing at this point. Nothing is going to happen. Color is chosen as chocolate. Chocolate color is obviously working for the brown color. So Control Z that, and I'll bring that. For range in 2, go forward 700 pixel, then make a 90 degree, then make a then go forward 400, and then make a right hand. Yeah. So look at this. What is going to happen? Let's keep it. Let's don't do this one. Let's see what happened. So remove partial codes and see what is happening in each of the codes. So we are going forward 700 pixels. So it means definitely we are going to move here to here 700 pixel, because if I'm here 350 to reach here, it will be 0 here, and then 350 here, so it will be 700 pixel, definitely covered, because my screen size is 800. So what I'm leaving is a cushion of this 100 pixel is a cushion, and this 100 pixel is a cushion which I'm not picking up. So I started at 350, because if I go from all the way to here, this is like 400, this is like 800, 400 here and 400 there. But because I started at 350, this is the point where I started, and that is where my cursor is currently standing at. This is where it is currently standing at. So this is a cushion of 100. Now I want to move 700 pixel, means that I'm going to move here, and then I move 90 degree here. So that's what's going to happen. And then I will add this line later on, add these two lines later on, but I will go and gradually add those two lines. So let's move on. And let it move. What's going to happen? And as you can see, if I do this, this is kind of misaligning. Okay, let me just clarify that. No, it's not there. Okay, let's run this. Stop this. Now let's run it one more time. So it has moved, and then it made a 90 degree, and it moved forward, and then it made a 90 degree. So once it made the 90 degree, it kind of created a triangle for me. Right? Here it is, as you can see. And then I want to go forward. Let me see if I have the right code. Just let me, I don't want to misguide some, because if I saved it, yeah, don't save it, because I want to make sure that you are understanding everything. I just wanted to go and check the actual code. Python. Turtle library. I think this is my turtle race actual program. There you go. Yeah, so begin fill, meaning that when you are creating it, fill it as well. And because we are filling it, that's why we are seeing that here, that the chocolate color is totally filling up. And when we said begin fill, it will fill up. It will not just only draw, but it will try to fill up that part. Whichever direction it will go, it will try to fill up that part. So that is why begin fill. And that is why when you are done with this filling, it will be a complete rectangle. And when you say forward 400, it will create that forward 400. So when I will create this, so right now, if you look at this, this is ugly because it is filling it up and it is ending up at this stage. So when I will create a full fill 400, go further 400, it will completely be filled. So let's put those values one by one. Let's say put this value one by one. Control V. And that's why I'm doing it one by one. And as you can see, if I give a very small extra space, Python is very good. That tells me that it's not aligned. So I'm going to align it and it's done. And I'm going to remove this right now because I don't want to create any further angle. But you will see when it will be there, when you go 700, then you made a 90-degree, then you go 400 down, right? Then you made a 90-degree again, and now you are going to draw again. Once it goes there 90-degree, it will be drawing that. So let's see and remove this part. Let's see how far it will go, where it is standing after that. So you'll be able to understand that. So run without debugging. Screen is here. Here you go. It has done some part of it. The part of it is kind of hidden here because it's really not showing. But if I go, whatever be the difference in the pixel is remaining, to make it a perfect triangle, perfect rectangle, I will just go and create a right angle triangle. So it will be a complete right and make it a fill. So let's put this here and then run it. So see, every line has a meaning to it that we are doing here. There you go. It did create a complete for me. So it does it in two loops because the first loop will create so once this loop is completed, it will do a complete loop, and then the other loop will complete the rest of it. Remember when we were making a star, we did completed the star in in 5 loops. After that, I created 7. I moved it to 7. It didn't really made any difference. That's what I'm saying, that once from where you started, then you created a 90-degree angles, right? So this is the first 90-degree angle, this is the second 90-degree angle. But you also need to keep moving forward. So you will go further and then you create a 90-degree angle and then you create another 90-degree angle. So 4 times you are making 90-degree angles to make a complete square box. So this created our dirt part. And right now, each time when my program runs, it is waiting for the input, but I'm not, once I will be entering an input here in the bottom screen, then it will be exiting. But this is helping me that it is not exiting program, because if I remove this line, then it will be exiting the program. I'll keep the original program with me. So I have it. So this is, you are seeing that you are able to do some things in Python, like screen setup, headings, creating a square, creating a dirt, right? You can create so many things here. And now my other thing is, if I go back here, so far we have done in this line of code, we have done creating the window. We are able to create the dirt. Then we are able to actually also were able to understand where to put my heading. Now the next thing is I wanted to create this line, but I'm not going to explain it right now because this is the complicated part. This is a complicated one. Uh, I would like to place the turtles and creating a turtle. So creating turtles is easy. Let me explain that how you will create turtles. I'm not going to lose it. Whether it's Visual Studio Code or Notepad++, that's not a problem. So now we are going not to worry about the gap. Let's create each turtle. Not the idealist way to create turtles, but the I could definitely would like to have a function that will create all the 4 turtles by just passing the color. All the things, what is happening? Basically, what is happening? We are creating a turtle, let's say a blue turtle. So you can create turtle, you can create a line like a turtle or something, and then you can create a function and say that for that color, for that turtle, this is the name of the variable. Really doesn't matter if I create it as a black turtle, as long as my color that I'm choosing is cyan. That is wrong. For the blue turtle, it has to be a blue color chosen, right? So I should be able to choose blue color. So that should be a appropriate color based on the comment. The pink turtle is pink or magenta. Yellow turtle is yellow, and the green turtle is lime, or I can change it to a green. But let's look at it. When we look at it, 4 turtles were initially at these spots, right? This, 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 and this. Their x coordinates are all the same, looks like, but their y coordinates are a little different, right? And their colors are different. So I can change. Maybe I'll just keep it cyan because this looks like a blue. So I'll change it. So first turtle is getting created. I can call it as a cyan turtle or something, but because I'm calling it as a blue, that's okay. Turtle is created with the color cyan. Shape will be turtle. So obviously there will be some different types of shapes that are available. Okay. So that gives me another hint. Python turtle shapes. What are different types of shapes that are available? It could be a square, it could be an arrow, it could be used as a circle, it could be a triangle, or it could be a classic. I think we are using the turtle shape. Okay, let's do that. Maybe change it to a square. Can we change it? This is giving us a very good hint that what like quick Google search on the first page. If you are not able to look at for the items that you're looking for on the first page Google search, then you should not be in IT. Like you should be able to search these different types of shapes that are available. Geeks for Geeks is the one that is more popular these days, just for tutorial. For the answering and wrong corrections, Stack Overflow is definitely your friend. So if I want to change this to be, instead of turtle, let's copy this guy. Let's copy this guy and put it here. Turtle, blue turtle, and I'm going to call this guy as a, what are the shapes that I have available? Let's choose a square. Let's see if we have a square or not. That will be just, but it's a very good it's a Google search, so I think it should not be wrong. But let's play this. Here you go. My first turtle is coming up as a square, so I can make anything. It's not, it's a pity that it's not a car. They should have a car shape as well, but it's not there. But you saw that this turtle is appearing here at this place, and it's actually started from the corner, so somebody has actually animated it for me to move from here to there. Well, we'll see that where that animation is happening, but you see that where the turtle is being, the shape and its size, I can reduce the shape size to be 1. I can reduce the shape, increase the shape size to be 5. It could be as big as I want. And one other thing that we can do, instead of creating the dirt using this loop, we can actually create a turtle with the size maybe 100. I'm not sure. We can do that. Let's see. These are the parameters. These are the flexibilities that I have available. So why not just try it? So it's all up to you how you want to design this. It's very flexible in that sense, but let's see how big of a box that it will create. Ah, it's just an ugly turtle that actually took all of my screen. But you see that I can change the background this way as well. Control F5 is the shortcut key that I should remember. Somewhere it is trying to place it, but you got the idea. So I will just keep it to a normal 1.5. So all that is changing is I'm saying it, hey, when the turtle is created, move it to which coordinate? Minus 300 by 150. So looking at this chart, my x will remain the same, but my y will be decremented because my y is getting low and low, and it is actually after the, this will be my first turtle, this will be my second turtle, my third turtle will be somewhere here, my fourth turtle will be somewhere here. So my y will continue to decrease and my y will continue to increase negative value when I will reach here. And as you can see, they are all equally distant. This one, these, all these turtles are equally distant with each other. So it means if I am starting this as 150, this will be probably 100, this will be minus 50, and this will be minus 150. Let's look at the coordinates where they are. Let's go ahead, copy all these turtles. Copy all of these turtles, and now I'm going to post them in Visual Studio Code. So I have already created a blue, pink, and yellow, and everything is done. The only difference is the first turtle was at yeah, this is duplicated. First turtle was at 150. The second turtle is 50 with 100 distance apart. Then there's a 100 pixel difference for between 50 and minus 50, and then there's a 100 distance apart between minus 50 to 150. And when I will run this, all those turtles will be created and will be moved to these locations because they were created at the centered location. But when you say go to, it will actually drag that to their respective places. So let's run this now. Control F5 is the shortcut key, which I forget. Control F5. Here you go. So far so good. The screen is getting developed. Any questions so far in this? And you can create different shapes and sizes. As you can see, I can just quickly Google it what are the shapes that we can put up. Okay, just if you can pause your screen for 1 millisecond, I think 1 second or 1 millisecond, I think 1 second, yeah, 1 second before racing, so that everything is placed in there, then it will wait for 1 second. Now let's choose a destination line. Even right now, as I say, destination line is a tedious thing to be made, right? I can totally skip this part of the code for you to not understand it, but I want you to understand it because this is a very logical part that you might want to go over. We'll look into that later on. Turtles are now created. Turtles should start to run. Till which coordinate they should run? As you can see, they are just moving on which axis? X-axis only. Their y-axis will remain constant. Their x-axis will continue to move. Maybe I should choose a better color. Yeah, this will be a better visibility on the brown. Unfortunately, these are the colors that I have available, so I just chosen a better color. So they will be moving on the x-axis, meaning their x coordinate will be the one that will be changing. But we need to utilize some random number being generated. So what we are going to do, we are going to move them between 1 and 10 pixels, right? So each time they will be struggling to reach 10 pixel, 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 between 1 and 10. Between 1 and 10. The maximum they can go as fast is 10 pixel. So to be generating a number so that the turtle will move, I will come back to this while loop in a moment. The turtles should move 10 should generate a number between 1 and 10 and move forward on that. And we know how to move forward. Forward means move on x-axis. Exam question. What does forward do? Forward moves. Forward initially move. When I initially started, it moves to the axis and the angle where it is pointing to, and it will move towards that direction, that many pixel. My destination line that I have arbitrarily chosen is at pixel number 230. So this pixel is 230. On the x-axis, if they move on the positive number of x-axis, because this is my first quadrant, x and y both will be positive, but this distance from here to here is 230, and this is where my destination line actually appears. So I want them to reach at least 230 starting from this by randomly generating. And then, so what I'm saying, while all the turtles x coordinates value, this is returning. And what does return do? This is a getter function. Remember, in Java when we learned about what does getter function do, it returns me the value or the current value. But because the turtles are moving, we need to continuously check what is their current value of x coordinate. Who will return me the value? The xcore function will return me the current value of x coordinate. If it is less, keep struggling, keep running. What you need to do? You need to generate the random number. While you are doing this, keep the turtle moving. Okay. Once the destination is reached, okay, so this code is checking. If it is still less, keep moving, keep moving, keep moving, keep generating the random numbers. Because we have made the speed to be the slowest, this loop will continue to run, and that is why there's a lag. If I want to make this race run faster, I can just change it to 5 or 3 or 2. It will just happen in the speed of a second. But I don't want. I want to visually look at it. So I will keep speed to be 0 for all of the pen wherever I'm using the pen. Let's celebrate the winner. If the blue turtle will be the winner, what will happen? In this destination or in this game, if you're looking at, let's assume that the blue is getting a victory here. Easier to remember. If the blue is getting a victory, blue is ahead of time. Blue is ahead in time actually, and luckily the random number that it is getting generated between 1 and 10 is higher than any of those in the course of the race. If, for example, at this point of the race, from here to here, if the random numbers that is getting generated for blue one starts to get smaller, let's say 1 and 2 and 3, but this guy who is very closely in the race, his numbers are getting generated between 7, 8 and 9 or 10, then he will definitely will beat the hell out of the blue one, and this guy will win. But as it looks like, this one will be the winner. When they will reach the destination, because the loop will stop here when the destination of 230 coordinates will be reached, they will be this loop is saying and, not or. It means all the conditions have to be true, right? But look at these conditions. If blue coordinate is greater than pink's x coordinate and blue's turtle x coordinates are greater than yellow's coordinate and blue's coordinate are greater than green coordinate. So as you can see, slash is used for giving the multiple lines. So if you don't want to cram everything in one line, you can just give a slash and put it like this. So this is one new thing that you're learning in Python, how to give a new line. You can give a new line like this, right? And then this is an end, and then this is an end. So I can just, if I want to be very nice, I can make it like this, and look like, and when I press an end and then slash means use another line. And then if blue's x coordinate is greater than the green turtle x coordinate, then print blue wins. Then print blue wins. Let's leave it at that. We'll come back to this, go to this, and we'll come back to this in a moment, this part of the code. Let's see when the race is happening. If the pinks x coordinate is greater than the blue's coordinates or the yellows or the greens, then who will be the winner? Pink will be the winner. And let's print out pink wins. Forget about this code. We'll come back to it in a moment. So we now know that whoever will be the winner, and it's actually elif, not elsif in Python, whoever will be the winner will have the coordinate x coordinate value greater than all the other turtles. So pinks will be greater than blue, greater than yellow, and greater than greens. If I come back to the yellow turtle, if he wants to be a winner, his x coordinate will be greater than blue, pink, and the green. Then we can say that yes, this guy is the winner. And else, blue is not the winner, pink is not the winner, and yellow is not the winner. I can write this same condition for the green turtle as I did. Green will be greater than blue, green will be greater than yellow, green will be greater than pink, then green will be the winner. I don't need to write all of these situations because I know if this guy is not the winner, this guy is not the winner, and this guy is not the winner, who will be the winner? This guy. So I don't need to write all these copy paste and these conditions and change the color to green. I can just say else I know green is the winner and then print the green is the winner. Okay, so we'll come back to this part as I said in a moment because it's a kind of a repeat. Any questions so far? Let's forget about the blocks that I'm creating. These fancy blocks that I'm creating, forget about these at the moment. We are still a winner of this program. We can still are able to find the winner of this program by reaching the coordinate number 230 on the x-axis, right? So for that purpose, just so that I'm not confusing you with that destination line, let's remove that from the code as well. So this is not there. I'm going to copy all the code here, which is the exact good running code. Control A, delete this, Control. This is my actual code from where I started the class. And let's remove the finish line part because I don't want to make a fancy finish line. We will learn about this, but right now remove the fancy line. Okay, so we understand everything about it, how the screen is set up, how the heading is set up, how the dirt was made, how the turtles were made, how we waited for 1 second, then we are keep looking for the coordinates, generating the random numbers, keep checking the coordinates, who reached the coordinates, and then we are printing the blue guy win. And I haven't explained you this part. So let's see, is this good enough? Yes, it should be good enough for now. The fanciness we will add. So Control F5, and I should put an input here so I don't exit out of the program. I don't want to. I'll say input, bracket open, bracket close, run this program. These turtles are running. We don't see the boxes. But arbitrarily, yellow turtle moved there and reached that part. When the yellow turtle moved there, it kind of rotated 360-degree and increased its size a little bit more just to say, I am the winner. So I haven't explained you that part where it is getting rotated and increasing its size. Let's look at that. So I'm going to close that. You can see there's a yellow win written here, and this yellow win is coming up here because I printed it on the command prompt. I did not printed it on the screen. But sure enough, if you look at here, if you're not focusing, you are seeing there's a small thing that I'm mentioning here. This is a something screwed up, but as you can see, yellow win is showing up here, but yellow win is also showing up here in the command prompt. All I have explained to you is this yellow win, this part, this is green, this part, right? And you can see the pink wins is here, just misaligned a little bit, so I just should copy it here. It should be in accordance to what I have copied and pasted. It should be here. There you go. But yellow wins, and this is what we are seeing. But I've never explained to you what this yellow win, how this yellow win came, and this is because I did not explain to you this part. So what I want you to explain to you is that what I did is I'm going to do two things here. I move myself to the place -100 to 205, and remember, I think this is the same place. -100 and 205 is the same place where I put what? Just a heading called turtle race. But I actually want to change that for saying that turtle race. Obviously, I want to leave the turtle race there as it is, but I also want to add yellow wins within the same font size. So I moved my pen to this same location where turtle wins already written, but I wanted to add an additional text. Who win? Yellow wins. And then I'm just going to see one thing. Yeah. And then I want to rotate it 360 degree, but I don't want to do it fast enough because my pen speed is still, remember, it is 0. So 72 times I need to shift the right of that winning turtle. So 72 minus 5 multiplied by 5 is 360 degree. So what happens is when it reaches this point, it will rotate itself. This loop will run 72 times, multiply by 5, 360. So wherever it moved, it will move itself. And it will be a complete 360 degree that it is making. And then the shape size, I have increased that shape size to be from 1.5 to 2.5. And if this logic is applied to the yellow turtle, from here onwards, it applies to the pink, it applied to the blue, it is applied to the green. Any questions so far? So the race is working. Our hard part is done. We created the screen, we created 4 turtles, we placed those 4 turtles, we moved them to their respective locations, we generated the random numbers, we put them in a loop, we did so many things. We put them on a loop, we moved them, and we checked if their x coordinate has reached a particular coordinate. Once that is reached, then we rotated it and increased the size of it. Any questions so far? This I will publish into my YouTube channel today as well.